Hi guys, so in this video we're going to talk about high noon on page 79. So in high noon you're presented with an interesting situation. You have the diver that's traveling along the Ferris wheel and he's released up at the very top. Now what's so interesting about that? Well, we know that up at the very top, like if he were released right here, his initial velocity wouldn't be in the downward or the upward direction whatsoever because it's completely flat at the top. So he would be going this way if the wheel were turning counterclockwise. Now, if he were released right here, would he have any sort of, here instead, would he have any sort of downward direction? He would, because he would be released at an angle that would be somewhat downward. But up here, up at the very, very top at the 12 o'clock position, he has no initial velocity in that downward direction. So what does that mean? Well, that means that in terms of time, in terms of the speed at which or the rate at which he's falling, the time it would take for him to fall down to the ground, if it wouldn't really matter if he were just simply released, like if the Ferris wheel weren't turning, or if the Ferris wheel was turning and he had that initial velocity in the leftward direction. So let's first talk about number one, the time it would take for him to fall down to the ground. We know from in class that this distance between the top of the Ferris wheel, the 12 o'clock position, to the cart was 107 feet. So do we have a tool for figuring out the time it would take for him to fall this 107 feet? We do. Okay, we learned about it just recently. It's our free fall general equation, which is negative 16t squared minus v sub naught, or v initial rather, we'll call it v initial, vi, t, plus h. Okay, and this is all equal to 0. Now, we're looking for t. What's our vi in this case? Well, as we mentioned, he's not traveling in the downward direction at all. Like he has no initial motion in the downward direction. So this vi is 0. What is h? Well, h is the distance that he's traveling, which is 107 feet. So we could rewrite this equation as 0 is equal to negative 16t squared. This 0 term will all go away since anything times 0 is just 0. And we know that h is equal to 107. So you guys can solve something like this. You can use the quadratic formula like we've been using in class, or you can just use simple algebra. Like you could move the 16t squared over to the other side and do some division, take some square roots, and that'll lead you to the right answer. Okay, number 2 involves not the vertical distance, but it involves this horizontal distance. In other words, how far is he going to get this way, traveling to the left? And in order to answer this question, we need to first figure out the time, okay? And once you figure out that time, I'm not sure what the time is. I'm guessing it's going to be around 2 seconds or 3 seconds, somewhere around there. You'll be able to answer this question. We also need the initial velocity traveling in this leftward direction, which, as I mentioned in class, is 7.85 feet per second. Well, how does that help you? Well, we know, in general, that distance is equal to velocity times time. Well, we're looking for the distance. We're looking for the distance he travels left, so that's our unknown variable. Do we know velocity? Yeah, it's 7.85. And do we know t? Well, yeah, we figured out t in number 1, or you will figure out t in number 1. So that's going to go over here in place of t. And with that, it's just that simple. You should be able to solve for the distance he travels in the leftward direction. Send me an email if you have any more questions about this, and we'll see you guys tomorrow, Wednesday, in class. Thanks.